Okay, so luckily the package has been installed. Fine, great. So in today's example, as I said, we'll take one example on the strip chart. Okay, so we'll try to make use of the inbuilt data set which we have. That is your air quality. Last time we had used this. Now to understand the strip charts can be created using a function called strip chart. Okay, in R programming. And this function usually takes numerical values, numeric, you can say vector, or a list of numeric vectors. Okay, and drawing a strip chart for the vector is very simple. I'll just take a very simple example without any parameters. What we'll do is, first of all, I'll show you this structure of your air quality. We have seen this. So to see the structure, sorry. Air quality. This is the file which I'll be using. So let us run this. And these were the columns which we had. Let us create one simple chart strip using the column ozone. Okay, so we'll use this ozone and column and try to create one strip chart. Okay, the function, as I said, is strip chart. Into round brackets, we have to give the name of the column. In this case, it is ozone, so it comes from air quality. And put a $sign and the ozone field. Okay, I'll just run this one. Okay, and that's your strip chart. Now, you'll be wondering what exactly is all this. Fine, so, to just understand this a bit, okay. Now, if you look at this chart which we have got, we can see that the data is, mostly, clustered below a particular range. So you have this below 50, you can see this area. Below 50, the data has been clustered with only, only some, I think, few of them following below that, above that. And extreme above 150, you can find that only one observation or one record or something is above 150. Okay, so this data gives you a brief understanding about the distribution of your data, okay, in this particular field. Fine. So majority of the data we can conclude from this chart that it lies between 0 and 50. And there are some extreme values beyond 150. There is only one observation. So we can call that as some extreme value, okay, or we can call it as an outlier. That means that information which I'm getting from this particular record might not help me in my analysis. Okay, it might hamper my overall outcome. Okay, that is the reason. Now, to give a better view of this strip chart, okay, let us explore into the different parameters which we have. Okay, so some additional parameters like we have in the other plots also. We have this main parameter, which is used to give the title. Okay, we also have the similar parameters like your label parameters X lab and Y lab, which provides the labels for the axes. Okay, now there are two additional method which I would like to show you. So for that, let me type this content here. So I'll type the function strip chart and then I'll explain you some of the parameters here. The first parameter will be air quality, the name of the field which I want. So let us put ozone here and comma. Okay, let me go to the next line. The main, so I'm giving the main title of the particular, you can say, chart. So let's say mean ozone, say in parts per billion. Okay, that's all I'll put a comma. Let us give the labels for the x-axis and the y-axis. So x lab equal to, on the x-axis I would have this parts per billion, because we have this value from 0 up to 150 and so on. So I'll write here parts per billion. Okay, then your y-axis, because this is for the ozone field. So let us put ozone, the comma. Okay, now this is important, the method. Okay, the method equal to. Now, in this, the default one which we have seen here, there's one called overplot, but I won't show you overplot right now. Let us use the method called jitter. Okay, there's a method called jitter. It tells you how you want to present your points on the chart. Okay, now when we say jitter, that means it is going to, edges the points, not, it won't be stacked. There are three options which you can say is overplot, you can say jitter, and the other one is stacked. Okay, so if I say stack here, it will be, put on one above the other if it is from the same point. Fine. Jitter will help me spread my values. Some calculation is done, and it is going to help me spread the points. Okay, which are similar points, you can say, and it is going to plot it properly. Fine. So I can make use of this method jitter, comma. Let us. I'll show you the how it looks like. We'll set the color for this. Now I can, because I don't want the default black color. Let us give, say, orange. Okay, you can use any other color. Okay, and here you can see I have got this squares which is being displayed. I don't want squares to be displayed. We'll see there's a parameter called PCH. Okay, it's a parameter which helps me design which the point which I'm going to display. The design or the symbol of that particular point will be decided by this value. Okay, there are many values, you can explore it. Right now I'll give one, and I'll just show you the chart how it looks like. Okay, so let me run this one. Okay, here it is. So you can see this now, it has been plotted, and because of this method jitter, it has been spread across. You can see this one, even though might be it's belonging to, so, and these are your labels and my title. Now instead of using jitter, if I use stack, okay, if I use like STAKED stacked, okay, and run this, what happened? Invalid method. Is it stacked one? Sorry. Okay, so it is stack, and here you can see the points had been stacked one above the other. You can see the pattern changes. Okay, and the other one is overplot. I hope it is overplot. Right, overplot. So here you can see this. This is the way you can see your points are displayed. By default, the method is always overplot. Okay, if you want to change that method, then you need to specify. There's one more parameter which can help you, especially when we are using jitter. Okay, we can also specify the jitter value. Okay, so you can give jitter equal to, and you can see is used when the amount of jittering applied. So if it can be very basic 0.1 or 0.2 and so on. So if I give this and run it, what happened? Comma. Fine. So here you can see now, look at when I change this value, look how the things changes. So if I give 0.2, okay, you can see this jittering has happened, and it's displaying the pattern in a different way. Okay, so depending on this value also, your the way the points are plotted on your strip chart differs. Okay, now default value for jitter is always 0.1. Right? If you don't want to give this also, you can skip this one as well. So if I skip this, I'm getting some other value. So jittering happening automatically. It is taking the value on its own. Clear? Now, what about this PCH? Okay, let us give some other value. Let us give, say 2 and see what image I get. Okay, so I'm getting triangles. Right? You can give 3, you get all this plus signs and so on. Okay, my favorite would be 16. It gives you a solid circle, a circle which is filled with some color. So I can run this one, I get this way. Okay, so this value also, if you can, there's a list of values which is available. You can just go through it. It is always available when you take the help. So if I have to go here, okay, and type your strip chart. Okay, there it is. Fine, you can see this strip chart definition. You can look at this. Okay, and one more thing, the strip chart, when we are going to use it, according to this, is first of all, we need to have one-dimensional scatter plot. Okay, if you have a single field which you want to show it on the chart, then you need to, you can make use of the strip chart. Okay, and it's a very good alternative to your box plot, especially when the sample size is small. Okay, if the sample size is bigger, then this plot is not going to help you. Secondly, here you can see all the methods which are there. So you can just go through them if you want. Okay, and you can see this method overplot is there, jitter value is given, offset, and all this. If you want, you can just go through them. Okay, you can also do grouping. Plus, you can also pass, functions as well. So instead of like, if suppose there's one example which they have given here, yeah, this one. So here you can see this is for grouping. So this value decrease will be grouped as treatment. Okay, so we'll take one example of this as well. Okay, so please, when you're using this function, you can just take a look at the help, and you can go through this description which is provided on your strip chart. Okay, so in other words, you can call it as a 1D scatter plot. Okay, 1D scatter plot as well. Whenever we have multiple values, two values, and you can put a scatter plot, 2D scatter plot, usually using your scatter function. Fine. So that is my strip chart. Let us have and let us see whether we can have multiple strip charts in the same frame. Okay, so for that, what we'll do is let us prepare a data for temperature. Okay, so I'll have one temperature field. So I'll make one field here. Last time we had made one, I think. So just 1 minute. Let me click inside here. So temp, that is what I'll be making. And I think we had made it, but still I'll just for your convenience, I'll do it again. So air quality, the $sign, temperature. Okay, that will go in. So let me press control. That creates my file. Then I'll generate a normal distribution with the same mean and your standard deviation. So for this, I'll create another field called temp norm. Okay, that is what we had created last time. So temperature using normal distribution, and which was the function, if you remember, it was R norm. So this was the function which we had used. Okay, the first parameter would be how many values I want. Let us say I want 200. Okay, comma, pass the mean value, mean equal to mean into bracket, the temperature field, so temp, comma, and I want to ignore, I want to drop my NA values. So all my NA values will be dropped while calculating my mean. So for that, I need to use NA.rm. RM is to remove the null values. I'll give true. Okay, so it is going to remove my null values. Give a comma, I'll just press enter here. Second is your standard deviation. So I'll write SD equal to SD into bracket, temp, comma. Even in this case, I want to drop my null values. So I'll give NA.rm equal to true. Okay, so this will create me, it is going to generate a normal distribution with the same mean and standard deviation from my database or the data set which I have. Okay, so let me run this one. Okay, so Another field got created. Fine. Let us make this as a list here. So what I'll do is I'll create a list first. For that, I'll create, let us say X, I'll use X here, X equal to, and how do we create? Using the function list. Okay, so list is my function. Into round brackets, I'll give, say temp equal to temp here, comma, that is the name which I'm giving. And for normalization, normal value, normal distributed value, I'll give norm, like this. And this is equal to your variable which we had created, temp underscore norm, this one. And so let us run this as well. So X got created, list, you can see this here. This X is list of 2. Okay, so if you want to see this, you can click on it, and I've got temperature, integer, some values, and here we have normal distribution around 200, which we have created, and some values are there. Clear? I'll close this. Now, using this values, we can make 2 strip charts with this list which we have. Okay, so I'll just copy this function down. Let me copy this, and we'll paste it here. Fine, I'll make some changes. So instead of giving ozone here, now I'll be using temperature. Now, because I have already put it in the list, I'll give X here. Okay, and let me change the title as well. The main title, I'll write multiple strip chart. Okay, so, and multiple strip charts basically helps you, compare the 2 columns if you want. So here I'm going to compare the temperature, the real one, the exact one, and the temperature which I got from your normal distribution using the same mean and the standard deviation of the air quality temperature field. Okay, so multiple strip chart for, let us say, for comparison of temperature. Okay, this a bigger title. Fine. On the x-axis, I'll put some degree in Fahrenheit or something like that. So let us put DG dig and FAH Fahrenheit. And on the y-axis, I'll put temperature. Okay, so this is T. I'll put it capital. Okay, the method, I'll keep it as jitter. Now, this is the color because I have now 2 different variables which I'll be using because there are 2 lists here. In the list, I have 2 variables here, or 2 columns, you can say 2 different ones. One is temperature and the other one is your normal temperature based on the normal distribution. So the colors should also be different. So I'll use 2 colors now. Let us give orange, and the second one, let us give it as red. Okay, so 2 colors required. I'll put the round bracket and I can put the comma. Okay, I'll keep PCH as 16 so that I get a proper distribution. Let us run this one. I hope commas are there. Fine. Yeah. So here you can see, as per the temperature which is actually observed and stored in my database, I'm getting this plot here. Okay. So this is my, you can see this temp. Okay. And the normal, through the normal distribution which I got these values. Okay. These values came from the normal distribution. Okay. So if I want to create, multiple, you can say for especially multiple strip chart for comparison, you can always make use of list. Okay. So either you can use a vector. Vectors, especially when we have only 1 strip, and multiple strips. If you have multiple strips, you can make 2, 3, 4. The number, it's up to you. Okay, you can just create a list first and then use it. Fine. Now, the last example for the strip is through a formula. Let us say I have a formula with me, which I want to use for my strip, and I want to group it by the month. Let us say I want to group the temperature by month and display it using the strip chart. Okay, so how I do that? Now there's a, you can see a function which can be given. So I'll just copy this function again. Okay, and paste it here. Now I won't be using this. Just 1 minute. Let me paste this one. So I'll copy this one. Paste it here. Fine. Let me make a change. I want temperature again. I don't want ozone. So I'll change this. I want the temperature. So I can give temp. Okay. Now temp is here the field which I'm picking up from the data set. Okay, because I'll be mentioning the data set. I can give the tilde sign. Okay, and I want to group it by month. Okay, so the first parameter is the first field here, you can see, is the field which has the numerical value. Okay, or the value which I want to group. And I want to group it by this field here, which is month. Okay. Second parameter here, I need to specify the data which from where I have to pick up. So data equal to, because the name of my data set is air quality. Okay, this one is my name. Give a comma. Now the other parameters remains the same. So I'll just change this. I'll say, remove this one. Let us say different strip chart for each month. Okay, or you can write month-wise. On the x-axis, I'll put months. Okay, on the y label, not the y label would be temperature. Okay, so T, I'll keep it capital. Find the option here. I'm not going to give jitter because now I'll use the default one. I'll just give the color. So I want, let us keep orange only. If you want, you can move and come up with something else. Now there's one more parameter which I have to pass here. Okay, and that parameter is the group names which I want, like the month which we have. So group name. So I have to give group dot names equal to, and here I'll use the function C to give the months. So I have, say, May, let's give June, July, August, and we'll give September. August and September. Now it's up to you how many values you want to group it by. You can pass it here. Okay, I'm sticking to 5 right now. Fine, put a comma. There's another way. One more thing which I can do is I can get it vertically. Okay, there are options of vertical and horizontal. So I can just write vertical equal to true. Okay, put a comma. I'll keep the value as 16 here. Let us run this. I hope it's, yeah. So here you can see now. So this is my month May, and you can see this is the temperature which is grouped together. Fine. So I have got a strip chart. Okay, and the temperature has been grouped as per month. Okay, I'm able to set the, you can say, the group names as well. So I've got only 5 months which I have plotted here. Okay, if you want, you can just ignore this group names and check what output you get, and you can do some R&D with this. Okay, there's another one option if you want. And remember one thing, in this, the method should not be specified. The method should not be specified, especially when we are grouping it. Okay, do not specify the method. Okay, it is by default, it's going to take that method, and group it together. Okay. So this is the example which I wanted to take. This is the last chart for, and let's go ahead, and because I have already installed, let me create one more file. Let us go to EDA. Okay, let us go to EDA. And first of all, let us try to understand what EDA is all about. So EDA process, you'll find that whenever you get a project, okay, the first thing you're going to do is you're going to ask for the data. Okay, so data is provided to you by someone, might be the third party, or you might be collecting through some Google form or some survey or something or the other. Okay, so basically when we talk about EDA, EDA can be said to be a process of analyzing and visualizing the data to get a better understanding of the data. Okay, and what is the main ultimatum or the use of this particular data? After understanding, finding some insight from it. Okay, so there are various you can say steps which are involved, but there are some common steps which I'll just will discuss, and which if you master this 4 steps, you would be able to analyze any sort of data. Okay, so the 4 steps which we will look into is the first one is importing your data. Okay, importing your data. Now data can be, as I said, can be either in different formats. Okay, and the example which I'll be taking today, okay, we'll use the CSV file. Okay, I have one I have downloaded from Kaggle, a CSV file, and we'll be using that. Okay, so first step is always importing the data. Second is to clean the data. Now, cleaning data is very important, because if the data is noisy, you're going to get some weird output. You might not get the exact insight which you're looking for. Or you might get a wrong insight, based on which if you make some decision, okay, it can land up into a big problem. Right? So it can happen that you are not able to remove the errors or the problems of some you can say unwanted data from the data set, and you landed up with some wrong insights. Okay, it's very much possible. Okay, so the second step is very important. Okay, and when we clean the data, until and unless you understand the data, you cannot clean it. Please remember. So the first few, you can say, hours or days are spent on data, to analyze the data, to understand what the data is saying. Okay, sometimes what happens, even the column names are given to you in a different form. Okay, so for that you need to get some metadata from the provider who tells you what column is representing what. Okay, and for better better understanding of the columns, you can change the name of the columns as well. Right? So changing the name, reshaping the data, removing the null values, or removing values which were mandatory but which was not entered. It happens, sometimes wrong data is given to you, some garbage value is entered, so many things can happen. Okay, so cleaning data is a very important step, okay, in your EDA. That is your second step. The third step which is there for your EDA is processing the data. Okay, now while processing the data, you can make use of the various functions which we have. Now in this example which we will be taking, okay, there are some packages which I'll be using and some functions. So these packages might be a bit on a heavier side, because it does take time to download it and install it. So please see that you download. I'll just give you the names as well, okay, when we come to that. So using different inbuilt methods and some packages which are available, we are going to do that. We are going to process this data. And ultimately, the last step is usually visualizing your data, presenting your data in a visual format, okay, which gives you some insight. Okay, that is basically, these are your 4 common steps which you should follow whenever you analyze any data set. Clear? Now, the topics which I would like to cover when we are talking about this EDA, would be there's a package which is tidyverse. Okay, it's like this: TIDYVERSE. Verse. Now this is a package which is required. So see that it does not come with the default application, the software. You need to install this. Okay, so you need to install this tidyverse. Second package, which we'll be using for, especially for your visualizations. Okay, tidyverse is used for cleaning your data. Okay, so that's the reason it is tidy. The name itself indicates we are going to make my data tidy. Okay, and for visualization, I'll be using ggplot2. Okay, I'll be using this one, ggplot2, for my plottings. Okay, I'll also show you correlation. Okay, a correlation plot will be done, but that's not a part of your syllabus. It's something advanced. Okay, but because I'm taking a full-fledged example, I would like to show you this, and you can go, and the function or the package which I'll be using is CORR plot. So see that you install all these 3 packages. Okay, and be ready. Suppose especially those who are doing simultaneously should be ready with all these 3 packages. Okay, for today I'll just show you some small thing. Okay, and we'll stop there, because I want you all to get these packages installed, and then we can start over. There are some functions I'll be using, like your cbind and matrix, the ones which we have already used before, or functions to strip, str split function, or there are some functions to clear some data from some values from your data set. All those functions I'll be using, but these are the basic 3 packages that needs to be installed. Okay, so in my case, I've just installed tidyverse. So for that, let us start with the first step. So as I said, the first step, the step number 1, okay, is to import the data. Okay, so let us import the data. Okay, step number 1. Now for that, before we actually import this data, we would open this data and have a look at this data in Excel first. So for that, I have to go to Excel. Okay, and I have this PISA score. Okay, this is the data which I've downloaded from the website. Kaggle is the website. If you want, I'll provide this file in the Google Classroom so that you can practice on it. Okay, this is a look of the data which I have. Okay, it has the name of the country. There's some code there. There's some serial name, series name is there. Then the series code is there. And we have some years out here. There are basically 3 years, I think. Yeah, we have 2013, 14, and 15. Okay, now these values of 13 and 14 are null values. These are dots which indicate null values. Okay, so wherever we have 2 dots, these are your null values. Okay, the last column looks like a numerical value. The rest all are looking like a factor. Okay, why factor? Because you can see some data is repeated. Okay, you can see the data is getting repeated here. So something values might be repeated. So I'll consider, so how many records? First of all, let us go to the end now. Okay, so this is my data, and I hope there's no garbage value at the end. Fine, there's nothing. Okay, so this is my value, or this is the look of your data set. Okay, let us go back. I'll just close this, nothing to change here. Don't save. Okay. Now, there are 3 ways in which I can import my data. Okay, let's look at each of them. Right. The first one is, okay, of course, I'll be using the read.csv file only. Okay, the function which I'll be using is read.csv, but I'll show you the difference between, so let us put this one because I have used it. I have one df.raw. Okay, this is the data frame name which I'm using, and I'll use read.csv. into the bracket, you can give the name of the file. So if file equal to, now the file name was Eda something. So let me go back to Excel. Okay, this is the name of the file. I'll just copy this file name and use it here. So file, let me do something, save as. I'll just copy this, cancel this, come back. Okay, you need to use some tricks. So I'll give this here .csv. Okay, that's the name of my file. Right, this is the file. There are some parameters I'll be using here. Okay, the first parameter which I would like to pass is giving the file coding, the file encoding. And by default, it is, in many cases, you'll find that you might have heard about UTF-8. Okay, UTF-8 is some file coding. So let us give file coding first. File encoding equal to, in double quotes, put UTF, okay, in caps, -8 -BOM. Yeah, BOM. Put a comma, and just 1 minute, let me reduce this a bit. Okay, I'll clear this one. Fine, I want to see the packages. Fine. Okay, this is one parameter. And the third parameter which I'll be passing, first parameter was the name of the file which I wanted to open. The second parameter is the encoding style which I want to mention. And the third parameter is about the NA values. Now, what I want to do about the NA values. So there's a parameter called NA.strings. Okay, so I have to specify the NA values are presented by 2 dots. So I need to give 2 dots here. Just now we saw that NA values are presented by 2 dots. Okay, so this one way of using the opening the file and importing the data. The other way is using say raw1. I just give read.csv and I mention the name of the file. That's all.